How can IoT help us turn over 5,000 kilometers of pipe from being a black box? My name is Simon Granath. I work as a development engineer at Vasyd. Vasyd is a municipality company that's responsible for the sewer, the drinking water, stormwater, and waste handling in 5 different municipalities in the southern of Sweden. And this sector is quite conservative in Sweden and probably in the most parts of the world. You like to do what you've always been doing, and that's why me and some colleagues were recruited to VSyd for 2 years ago to try to change this, to make sure to implement and to try and to test new things. So our only mission when we were recruited was that we need to dare to test and we need to dare to make mistakes. We have a big challenge because, of course, we have a very old infrastructure. For example, one of our oldest pipe is that's still operating is from 1870s. So it's even before the light bulb was invented. And we have a big trouble with getting access to our pipes. Everything is dig down. So, of course, it's very expensive for us to install measurement points. And we have over 400 plants and pumping stations and so on that provides over 500,000 people. And this is things that must work 24/7, both today and in the future. So the big challenge here is also that while we have this old system, we see that the climate change is affecting us. We see that the weather patterns are changing. We have more periods of droughts. We also see that in the long term that it might be a big trouble with the rising sea levels in some of our municipalities that's on the coastline. And of course also the urbanization, because the system was built many years ago before it was in this state, and it's more and more people are moving into the area. So our system then, over 2,000 kilometers of drinking water pipes, and we have 1,900 kilometers of sewer pipes and around 1,500 kilometers of storm water pipes. So you can say that this is our black box, as I mentioned in the beginning. We do measure a lot of things on our plants and stations along the way, but in between, there's not so many sensors at all. And for example, that we have water losses for about 10% from when we take the water from, for example, a lake until it reach the customer. So 10% is very low in an international perspective, but still it's a big volume because it's around 5 million cubic meters each year that gets lost on the way. And on the sewer pipes then, we have around 50% additional water in the sewer system. It's quite general in Sweden and many places around the world, I would say. It's because that we have drainage that's connected to the sewer. We have groundwater that's leaking in. So this is water that's already clean. It doesn't need to go to the wastewater treatment plant, but it does, and this causes a lot of different troubles with overflows of untreated sewer, but also, of course, basement flooding. So we know that we need to measure more, and where can we do that then? We have a lot of different things here on our pipes. We have around 9,000 fire hydrants, 54,000 wells that are connected to the sewer and stormwater system, and also 73,000 valves on the drinking water. And of course, 60,000 households, where also an excellent place for more measurements. So some examples on what we do and what we want to measure more of. We do install flow meters on the drinking water pipes. As this example, we need to dig up the pipe, install a flow meter, and we know how much drinking water that's going into an area like this. But of course also that we want to connect in near real time how much water usage the consumers have. And there's a lot of different things that we want to measure on the way. For example, pressure is a very important parameter for us, but also loggers that can detect water leaks. This is things that's not so IoT related today. The smart meters in the households are starting to get that, but still a lot of sensors are hard to connect. But we're working on it, and IoT is definitely one of our solutions for that. On the sewer system, we do some small tests. We need to measure the levels so we know how much water there's in the pipes. Water temperature, for example, is one other example, but also, of course, how much flow that's running in the sewer pipes. So IoT then, we have focused a lot recently on LoRaWAN. We have installed around 15 gateways by ourselves and have around 5 to 10 more on the way in the near future. So the reason for us to choose LoRaWAN, it's basically because we have quite high security issues for us that we want everything to be installed on-prem. We want to control most of the data flow. We don't want anything to go on the cloud. And also that it's a lot of more sensors available for LoRa, and that's very positive for us. So, of course, narrowband is also very interesting for us because of the good coverage. But basically, we have not done so many tests so far because of the few number of sensors that are available to buy. So, our biggest IoT project so far is that we are right now installing over a number of years 65,000 smart meters at our customers' household. So this sensor are gonna send data 6 times every day, and it's about the water usage and different alarms. So the battery lifetime is approximately 16 years, but the minimum requirement is 12 years because we then done a big tender on this. And we did define in this tender that we must have had a minimum requirement that 98% of the meters must send data at least once every day. And that's quite difficult, I would say, to many companies to achieve. But we did actually get a good project on this. The winner of the tender had a good solution to solve how to get so much data to us. So basically, the smart meters are being able to send data to both Vasyd's own gateways, but also other companies' gateways, because many different companies, except for Vasyd, are doing a lot of different things with LoRaWAN and have their own gateways. So we have a very good way here to start collaborating, and we are doing that by a net operator in Sweden. So basically the data is going through different gateways through the net operator until it reaches to the Ygio IoT platform that's installed on-prem on our own server. And we also have the joint server on-prem, so everything is encrypted from the meter until it reaches the on-prem IoT platform. So the only thing that the net operator can see is the metadata, the SF grades and the battery lifetime and some other different meta parameters. And later on this, we connected to Node-RED, where we send out data to customers. We send it to an own Influx database and to a lot of different internal systems to analyze this data together with many other data sets that we have. So we have some main challenge in our organization with working on IoT. One of those is that as I said in the beginning, everything is underneath the ground. And we also have the cast iron lids. And that's big trouble for us to get the signal out of those lids. And also on many applications, especially on the sewer system, it's a big problem with that the sensors are basically too cheap. You can see that the quality is quite bad. They won't handle the rough environment that's in the pipes. So even though, say, like 10 years of battery lifetime, it's more or less like 6 months on many applications because of this. So one more thing is that it's quite time consuming for us to go out and install many different sensors after we install different pipes and valves and so on. We would like to see in the near future that more and more companies do integrate the IoT sensors when the products are being produced, so we don't have to go out there after. And for us, as a quite strict no-cloud organization with want to have everything on premise, a big challenge is that so many companies lock their own hardware to a cloud solution or to their own software. So of course, we want everything that we connect with IoT to go to the Ygio IoT platform, but still many companies won't allow this, and that's quite hard for us because we can see that the best sensors out there might be locked to their own software, and then we won't buy it, unfortunately. And it's also a big thing because we don't actually have a good organization to handle the monitoring and the maintenance of the sensors at the moment. So to get as maintenance free as possible would be great, and we are trying to get an organization to handle this, but we see that in the future that we have over 10,000 different IoT sensors, but it will be a challenge to maintain all of this in a good way, so we can also trust the data. But one of our also big challenges that's more internally, it's that we are only a few people today that works on IoT to try to test new technologies, to implement new kind of sensors and new ways of data analytics and so on. And we really need to focus more on the cultural transformation, and that's a very important thing in the more general digital transformation that we're working on. So there's a lot of work that needs to be done in our organization with building up a leadership that encourage the innovation and new ways of thinking, so we can be have so many other people in the organization except for 1, 2, 3 people that's going for this. And that's when we can really work on IoT in a big scale, when we have this cultural transformation on going. I would like to say thanks for listening, and please contact me if there's any questions afterwards. And yeah, thanks.